mechanical energy, which is our ME, is our total energy. So that's our kinetic and our potential together. So we have our mechanical energy is our total energy. So it is our energy of motion, which again is kinetic, plus our energy I was going to say energy of position, but we'll change this, sorry, to our stored energy. It's a little easier. It's our potential. So we have a formula for this one. So our formula for mechanical energy is our kinetic energy plus, not multiplying this time, but adding our potential. Now, on that one, you can use GPE or potential. It doesn't really matter. Okay. So this is our formula. Let's box that in. All right. Now, if you wanted to, you could solve this with a little bit of a harder formula. So you could do our mechanical energy equals, and then it would be our kinetic energy formula, which is our mass times, or I'm sorry, our potential energy formula is, I'm getting all confused here, sorry. Kinetic energy is 1/2, sorry, I'm writing faster or slower than I'm thinking, 1/2 times our mass times our velocity squared. Okay, and then we would add our potential, which is that mass times gravity times height formula. So you would just write it out like that. But a lot of times if they give you the potential and kinetic, you don't really have to solve for them. So I'm going to give another example of someone jumping off a cliff. Okay, so let's say this is our example right here, and we have Bob again. So if we have Bob jumping off the cliff, when he starts, we're going to call that position A. Then when he is about to here, we're going to call that position B. So he's falling, he's cliff diving. Here we're going to call this position C. And then right before he hits the water, I'm going to call that position D. Now, keep in mind that the ground is actually about here. So he still has a little bit to go through the water, which is good. So we're going to make 3 categories. So I'm going to use different colors to kind of help. So I'm going to have my GPE here. Okay, I'm going to have my kinetic energy here, which is again the energy of motion. And then I'm going to get another color. Let's see what other colors I have. We will go with blue. Let's hope this works. Blue we're going to say is mechanical energy. Kind of looks like the green, but that's okay. So let's say, and I'm just going to give some easy numbers. These are not realistic in any way. But let's just say that when he started, right here, he's overcoming inertia, so he really doesn't have any kinetic energy. He hasn't moved yet. So I'm going to say that my kinetic energy is 0 joules, and my gravitational potential energy is 100. So when you do 100 plus 0, my mechanical energy is 100 joules. So at position A, that's his energy. When he starts to fall, he's picking up speed. So his kinetic energy should be increasing, but he's getting closer to the ground, so his GPE will actually get lower. So let's say, and I'm just assigning random numbers to this, let's say his GPE is 78, he decreased his gravitational potential because he's not as far off of the ground, but his kinetic energy will increase because he's going faster. So let's say he's at 22 joules, which adds up to our 100. Now, what we keep in mind is throughout this whole system, he's not really losing energy. So his mechanical should stay the same. So I can go ahead and fill that in as 100 joules all the way down. So the whole time he's going to have the same amount of mechanical energy. What will change is his kinetic and gravitational potential, but they will still always add up to that 100. So let's say down here, he's down to 42 joules of potential, GPE, but his kinetic is obviously getting higher because he's going faster, because he's falling and gravity's pulling down on him. So 58. And then let's say here he has 12 joules, because he still has a little bit of distance before he hits the ground, so it wouldn't be 0 unless he's on the ground. And then let's say 88 joules for position D for kinetic. So he's going pretty fast when he hits that water. He's going to cliff dive. He's going to be fine. So one of the things that comes into effect down here is our conservation of energy law. So I'm going to write that here. And I know you guys have learned that before, and we've learned it in class. But the law of conservation of energy. Okay, this is big, so we're going to cloud it. So the law of conservation of energy states that the energy is not going to really be lost. It's just going to be rotating between, it's going to convert from GPE to kinetic. So we're going to talk about that. So I'm going to make 3 little areas to take some notes. So the first thing is that our GPE, okay, is actually going to decrease. Okay, it's decreasing. Let me find my pink highlighter. Decreasing as he falls because he's getting closer to the ground. So we're going to write because Bob is not as high off the ground. Okay, but his kinetic energy is actually going to increase as he falls. Okay, so his kinetic energy increases as he falls because he's picking up speed. Okay, but his mechanical energy, and sorry for my handwriting when it's at the bottom of the notebook, it's very hard to write, but his mechanical energy stays the same because he's not losing energy, it's just converting from GP to kinetic, okay? So he's not losing energy. Okay, so as he's falling, the GPE, which was high at the top of the cliff, is converting to the kinetic because he's moving faster and getting closer to the ground. So that is what we would consider for the kind of change of energy happening in that example. Those are the 3 main types of energy that we focus on in the 8th grade. Obviously, there's a ton of different types of energy, like thermal energy, and other ones, but we are focusing on these. So if you have any questions, comments, concerns, please comment in the area below. I hope that Unit 7 is making sense. Obviously, this is just touching on all of the different lessons, but you are more than welcome to do your own research or look in your book or your notes packet that I gave you for more information. Hope you guys are doing well. If you guys have a unit in particular that you need me to focus on, if you like these videos, please tell me. And I hope you guys are doing great. I hope you guys have a wonderful spring break, and I will see you soon.